Okay, let's have a look at question 7. Given that k is a positive integer, show that this integral is independent of k. So integral 3k, k, 2 over 3x minus k dx. Okay, first I will just take 2 outside. So that'll be 2 and then 3k, k, 1 over 3x minus k dx. And then this is a fraction, and then the denominator just a linear expression. So that's just ln. Yeah. So that would be ln of 3x minus k. And then always remember, if it's a linear expression, we divide by the coefficient of x, which is 3. And we put 2 back, and then with limits 3k and then k. So now we just have to substitute in the limits. So we have 2 over 3 ln of 3 times by 3k minus k, and then minus 2 over 3 ln of 3k minus k. So simplify that. That would be 2 over 3 loss of ln. So 3 times 3k is 9k minus k is 8k, and then minus ln of 3k minus k, which is 2k. And because when you minus 2 logarithm with the same base, you just have to divide those two. So 8k divided by 2k, that's just ln of 4. Because 8k divided by 2k, k over k cancel out, 8 divided by 2 is 4. So there's only number left, which is independent of k, because there's no k in this expression. So then we show it. Part B, show that this integral is inversely proportional to k. So if it's inversely proportional, eventually we want to have the answer in the form of some constant over k. That's called inversely proportional to k. So if it's directly proportional to k, then that should be some constant times by k. And if it's inversely proportional to k, that would be some constant divided by k. So that will be the form we want at the end. So if you get that form, then that'll be the final answer. So let's have a look. 2k, k, 2 over 2x minus k about 2 dx. So then that will be 2k, k, and then 2 times by 2x minus k to the power negative 2 dx. And then because this is again just a linear expression, so we can plus 1 the power divided by the power. And then again, it's a linear expression. We need to divide by the scale, the coefficient of x. So we need to divide by 2. And then we still have a 2 at the front. So 2 over 2 will cancel out. So it's just left with 2x minus k to the power negative 1 over negative 1 with limits 2k and k. So simplify that. We have negative of 1 over 2x minus k with limits 2k and k. So now if we substitute in limits, we have negative 1 over 2 times by 2k is k, and then minus negative 1 over 2k minus k. So that's equal to negative 1 over 2 times 2k is 4k minus k is 3k, and then plus 1 over k. So to minus them, we can make the same denominator times by 3 times by 3. So 3 over 3k minus 1 over 3k. That's equal to 2 over 3k, which it has the form something over k. So therefore, it's inversely proportional to k.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.